Welcome. My name is Terry Stringer, and today I'm going to give you an introduction to Hydrology Studio. We'll begin with a quick overview of the software's user interface, and then I'll walk you through a sample watershed modeling project. What our users like most about this software is its straight-to-the-point user interface. Everything is right there in front of you without the typical maze of dialog boxes. You're much more productive, and you'll be more confident about your work. Most watershed modeling functions are selected from the ribbon menu located at the top of your screen, which contains two tabs labeled Home and Edit. There are three unique sub-tabs for which you can display and process your work. The Basin Model tab is where you visually construct your watershed schematic. The Table tab is basically a numerical version of the Basin Model, but with key computed results added. The Charts tab represents both graphical and numerical combinations of the first two tabs. So here's the basic workflow for building watershed models. You add hydrographs to your model by simply clicking one of the buttons in either the Runoff Hydrographs group or in the Process Hydrographs group on the ribbon menu. Your model should always start at its upstream end and work downstream. Icons representing each hydrograph are automatically inserted on the Basin Model canvas. Clicking an icon on the canvas populates this input window on the right. There you can enter or edit the associated input data as well as compute results. Hydrology Studio can generate up to 100 hydrographs per project, and each hydrograph may contain up to 8 return periods for a total of 800. So let's get started with an example watershed model. I'll begin by selecting Start New Project from the File menu. Next, I'm going to open up a background image of our sample watershed. We'll use this as our guide for constructing our model. This watershed consists of 3 drainage areas and an intermediate channel. Our task here is to develop the downstream hydrograph which outfalls into the lower horizontal channel. To model this watershed, we'll need to follow these steps. The first step is to develop runoff hydrographs for subareas DA1 and DA2. We'll call these hydrographs 1 and 2. And because they converge at the same point, step 2 combines hydrographs 1 and 2 to form hydrograph 3. Step 3 routes hydrograph 3 through the intermediate channel to create hydrograph number 4. Step 4 creates a runoff hydrograph for subarea DA3. And lastly, we'll need to combine hydrographs 4 and 5 to create hydrograph 6. For this example, we'll create our model using the SCS method while using a 6-hour IDF-based design storm for generating runoff hydrographs. I'll begin by clicking the SCS button on the ribbon menu. The program automatically places an SCS hydrograph icon near the top center of my working canvas. This will be DA1. I'm going to move this over here to better mimic our actual watershed. We'll work side by side. I'll click the SCS button again to add the second subbasin, DA2. Next, we need to combine these two hydrographs. Do this by first selecting them. And note that you can select multiple hydrographs by clicking them while holding down the Shift key or by dragging a rectangle around them. After they've been selected, click the Junction button on the ribbon menu. It automatically adds the corresponding icon to my model. Next, I need to route hydrograph number 3 through the intermediate channel to create hydrograph number 4. I can do this by selecting hydrograph 3, which indicates it's the inflow hydrograph, and then clicking the Reach button on the ribbon menu. My model is updated. Next, I'll create another runoff hydrograph representing drainage area 3. As in the first step, I'll simply click the SCS button. And that hydrograph needs to be combined with the channel reach hydrograph. So I'll select hydrographs 4 and 5 as I did in step 2. Then click the Junction button on the ribbon menu. There, my model is complete. You've noticed that I have repositioned the icons on the canvas to better mimic the actual conditions by simply dragging them around. You can also reposition whole groups of icons by holding down the Shift key while dragging. You can also have the software return to its default arrangement by clicking the Reset button on the side toolbar. I'm not going to do that now because I'm using a background image. Now let's add data to these hydrographs. You can add data to any hydrograph at any time. You can build out the entire model as we've done here and then add data, or you can add the associated data as you add individual hydrographs to your model. There's no particular order you need to follow, but you must start with the most upstream hydrograph and work downstream. To begin, I'll click on hydrograph number 1 and then fill in the blanks on the data input window to the right. For this hydrograph, its name is Drainage Area 1, or DA1 for short. Its runoff area is 2.5 acres. Its curve number is 80. And we'll enter a user-defined time of concentration of 20 minutes. Click Compute to render the hydrograph. Now I'll do the same for hydrograph 2, where its name is DA2. It has a drainage area of 3.0 acres, a curve number of 74, and it takes 25 minutes for a drop of water to flow from the most remote point in this drainage area to the downstream end. Clicking Compute generates the hydrograph. Next is the junction, hydrograph number 3, and I'll name it Confluence. Notice how the inflow hydrographs are already filled in based on the basin model we created. Click Compute to build the combined hydrograph. Next is the channel reach. Its name is Intermediate Channel. Its inflow hydrograph has already been set to hydrograph 3. And we'll use the Muskegon-Kunj method, or Muskie method as some call it. And the section type of this channel will be trapezoidal. The reach length is 1,000 feet at a slope of 0.1%. The channel roughness coefficient is 0.05. The channel width is 5 feet and has 2.5 to 1 side slopes. The next 3 items here are disabled because they're not required for this particular method. So clicking Compute generates that hydrograph. The next hydrograph is for Drainage Area 3, and we'll name it DA3. It has an area of 5.2 acres with a curve number of 76. And its time of concentration is 30 minutes. And clicking Compute takes care of that one. And finally, the combined hydrograph. And its name is Inflow to Channel. And click Compute. And that's it. The model is now set up, everything's computed. At this point, you may be wondering where these hydrographs are, numerically that is. So let's take a look. I'll first select, say, hydrograph DA1, and then click the Charts tab. Here we see a graphical representation of hydrograph 1. Now you can select from this list box on the left to view any hydrographs chart. Multiple selections can be made by clicking while holding down the Shift key. Use the Control key to select non-adjacent hydrographs. For example, hydrographs 2 and 6. Note that Hydrology Studio computes hydrographs for all active return periods at once. This frequency selector bar across the top allows you to choose which one to view. We'll cover active return periods in a separate video regarding rainfall and design storms. This chart, as well as any other chart in the program, can be zoomed by simply dragging a rectangle from the left to the right of the desired viewport. And then just double-click the chart to return to full extents. Other options include exposing the hydrograph's numerical data, adding a volume versus time plot, and an elevation versus time plot when you're doing pond routings. So let's return to the Basin Model tab. It's inevitable that once your basin model has been constructed, you'll need to make some changes. For example, the curve number for DA2 might change from 74 to, say, 81. That's easily accomplished by selecting the hydrograph, editing its curve number, and clicking Compute. And since DA2 is an inflow hydrograph to other downstream hydrographs, they will need to be recomputed as well. So this is easily accomplished by simply clicking the Run button on the ribbon menu. This recomputes all of them automatically, beginning from the top, and the entire model gets updated with a single click. Getting printed reports in Hydrology Studio is also quite easy. Reports are available at any time and there's no rigid procedure to follow or any preparation work. Just click the Reports button located on the ribbon menu, and Hydrology Studio displays a Reports menu. The Reports menu offers a wide array of report types, styles, and has lots of options. Feel free to pick and choose until you get to know the ones you like best. For this project, I'm going to select Basin Model, Hydrograph Summary, and Hydrograph Reports. I can choose a specific range of hydrographs, but in this case, I want to print all of them. And I want them as graphic rather than numeric. And for the frequency, I just need the 100 year. Now that I've chosen my options, I just click the Generate button, which opens up the document viewer where you'll see a preview. And then from here, you can send them to your printer. So this concludes our introduction. You've learned how to use Hydrology Studio, you modeled a watershed and got printed output in about 10 minutes. Hopefully this video will allow you to hit the ground running with the program and perhaps has sharpened your watershed modeling skills. Thanks for watching, and thanks for choosing Hydrology Studio.